Hello dear students of plus one medical and non-medical respected teachers. Today I am going to discuss the various formula of projectile motion. So let us start with the horizontal projection. And we know that when a particle is projected horizontally from a certain height h with velocity u, it follows a path like this. And this yb is known as horizontal range. So we can find velocity of projectile at any time t when particle is at pxy, h is the height of tower from where projectile is projected. No, as soon as the projectile is projected, it comes under action of two motions. One is uniform motion along x-axis, other is uniformly accelerated motion along y-axis. So from this diagram, we can derive all the formulas related to this horizontal projection using simple equations of motion. First of all, we study the trajectory of the projectile. So trajectory of projectile comes out to y is equal to kx square. So which is the equation of a parabola. So it means the trajectory of the horizontal projection is a parabolic in nature, which is symmetrical to vertical axis. Then time of flight, time taken to reach the ground, is given by t is equal to under root 2h upon g, where h is the height of tower from where projectile is projected. Then horizontal range, the maximum horizontal distance traveled by the projectile before striking the level of projection, striking the ground. R is equal to u into t, or u into under 2h by g, or it will be 2h u square upon g under. Then we can find velocity at any instant, say at point P at any time t. Velocity is given by v is equal to u square plus g square t square, and its direction tan beta is given by gt upon u, because beta the angle which resultant velocity makes the horizontal, and tan beta is given by vy upon vx. So vy is gt upon vx is u, because along x-axis there is uniformly non-uniformly accelerated motion. So then what happens when body is projected some angle theta with the horizontal? So theta may be the horizontal, theta may be the vertical. So formula will be different, but with a small difference. So the equation of trajectory path will be like OAB. Initial velocity projection u, which can resolve two component u cos theta, u sin theta. So u cos theta remains same throughout the journey because there is no acceleration on x-axis. That is uniformly, there is no acceleration along x-axis, uniform motion. And second is uniformly accelerated motion along y-axis. So k is equal to u square upon cos theta, which is a parabola. So it means in this case, angular projection path followed by the projectile will be a parabolic in nature, and this parabola is symmetrical to an axis parallel to y-axis. Time of flight is given by t is equal to u sin theta by g. Theta is the angle of projection. Time of ascent is equal to time of descent is equal to u sin theta by g. Time taken to reach the highest point, or time taken to reach the same level of projection from the highest point, both are equal, provided there is no air resistance. Then maximum height is gained by the maximum height gained by a projectile during this journey. H is equal to u square sin square theta upon 2g. Horizontal range OB is given by u square upon g sin 2 theta, and R is maximum when theta is 9 degree because sin 90 is 1. So our maximum horizontal range is given by u square upon g. That's why all like javelin throw, hammer throw, discus throw are thrown with at an angle of 45 degree with the horizontal, so that they cover maximum horizontal distance. So this technique is used in athletics also. So physics is everywhere. Velocity at any instant is given by v is equal to u square plus g square t square minus 2 u gt sin theta, or tan beta is given to tan theta minus g upon u cos theta t. Now, if we substitute the value of time of flight, if I velocity at point B, put t is equal to capital T and substitute value of 2u sin theta by g, you will get v is equal to plus minus u and beta is equal to minus theta. Means projectile will strike the ground with with same speed and in opposite direction at point B. Then we can say prove that there are two angles of projection for the same horizontal range, because r is equal to u square upon sine 2 theta. So u square upon g sine 2 theta can be sine 180 minus 2 theta, because sine 180 minus theta is equal to sine theta. So or 2 can be taken common, 90 minus theta, which is same. U square upon g sine 2 90 minus theta, r is same. So r can be written in two forms. It means the two angles theta and 90 minus theta for which range is same. That is, whether angle is made with horizontal or vertical, it will have the same horizontal range, but greatest height and other things formula may change. So there are two angles for the same horizontal range. If you have to find relation between greatest height and horizontal range, so h is u square sine square theta upon 2g, r u square upon g sine 2 theta. Divide h by r. So u square sine square theta upon 2g, h, r means u square sine theta upon g. g cancels, u square cancels. Sine 2 theta can be 2 sine theta cos theta. So 1 sine theta cancel. So h by r comes out to be 1 by 4 tan theta. 1 by 4 tan theta, when theta is equal to 45 degree. Tan 45 degree is 1. So h will be equal to 4 times, r will be equal to 4 times h. So it can be proved horizontal range is equal to 4 times the greatest height when theta is equal to 45 degree. Now, this was angle with horizontal. If projectile is projected by making angle theta with a vertical, with velocity u, then formula will change. So component of u along y-axis will be u cos theta and along x-axis will be u sin theta. So we have to interchange sin theta and cos theta. So when angle of projection is with the vertical, when particle is projected at an angle theta with the vertical, then most of the formula will change. So you can say time of flight will be 2u cos theta by g, or time of descent will be u cos theta by g. Change sin theta to cos theta to sin theta. H will be equal to u square cos square theta by 2g. But r will remain same, r u square upon g sin 2 theta, because sin 2 theta is equal to 2 sin theta cos theta. So change sin theta to cos theta sin theta, the formula remains the same. Therefore, that's why there are two angles for same horizontal range. Velocity will be u square plus g square t square minus 2u gt cos theta. So instead of sin theta we will cos theta, and instead of tan theta we will have cot theta. So this is the difference only. So this is all about the main formula of horizontal projection, vertical projection, angular projection with theta vertical or horizontal. So this is all about projectile motion. In next video I will discuss vectors. All the best, be happy. If you want to see the derivation, you can watch my previous video for projectile motion horizontal projection and projectile motion for angular projection. Thank you, all the best, be happy, good luck, stay tuned, all the best, good luck.